Hello explorers and welcome to another video. Today we are going to talk more about Ceph. We are going to add some drives to it and also talk a little bit about the saving of data in a Ceph cluster. So first off we switch over to my screen here, and here we see the Ceph cluster that we have, and where we left off we had the backbone up and running. And in this case that's 3 monitors and 3 managers, and we talked about the importance of having multiple monitors in order to have good redundancy in your system. But we see here also that we have no file system, we have no gateways, we have no OSD, so object storage device, and we have 3 hosts, but we have no raw capacity or anything like that. And how Ceph is actually saving information is using Rados. So that's reliable, autonomous, distributed object storage. And in this case we want to create some OSDs, object storage devices, that we can save data on. So let's switch over to our client here, and I will log into my first node. And if we look on the drive here, devices, and I know that I have SATA drives, and these are virtual drives, so I will not have any smart data or anything on those. But I see here that I have an extra drive here that I created, which is 50 gigabytes. If you are setting up a Ceph cluster, you will probably have multiple drives and a lot of storage that you want to share in your cluster, but having those spread out on multiple hosts and even multiple racks or data centers could also be really good. So let's prepare one of these drives. Then we do Ceph volume LVM, so we will use the LVM layer on a drive in order to save information about the drive. Positive thing about that is that we will have information on the LVM drive, so we can pick it up in another host. If the host dies, we can start OSD drives again just by this data, which I think is really cool. And we will prepare it, and the data drive will be dev sdb. So let's run that, and it will prepare that drive. A problem that I had in preparing this drive was that I had already ran through this and checked that I could do it, and I couldn't really get it up and running because I already had a prepared drive. So I needed to remove all those drives and then create new drives that was fully clear. I probably could have removed the LVM data in some way, but I didn't figure that one out. So here we see that it has created 0, which is the 0th drive, and it has prepared it and also given it an UAD here, so that it has an AD and it's the 0th one. If we look in our cluster, we see that we have 1 total OSD and it's currently down. So what we need to do now is actually activate this one. So to activate, we just run the same Ceph volume LVM activate. We will take the number here, the identifier, which is 0, and then we also need this identifier here, the UUID. So we will give it that, and it will activate that drive. And after a little while it will be up and running. If we look in the dashboard again, this will go from down to actually being up. And it also have created a service on our system which handle this drive. So it is a separate service, a separate something that you can connect to, and it actually will handle that drive to the network. So all data will go from an OSD to a client. But in order to know that the OSD exists, we have managers. Something that we didn't do earlier was actually looking into having all of these different services enabled so they actually start when we start a machine. And that could be really good if we need to restart the machine and so on. So we go system, CTL, push this up a bit. So system CTL, status, Ceph, mon, node 1. So that's active. we will just run an enable on that, and we will do the same for the manager. So those are now enabled and will start when the machine starts. You can also do a status on OSD and then the ID of 0. We see that that is up and running. We want to enable that as well. So now we have one OSD up and running. We can leave node number 1 and go over to node number 2. If we look here in the GUI again, we see that we have raw capacity of 48. We have no objects, we have no pages and no pools. So there are still no data in the cluster, but we have a little bit more raw capacity. And here we will prepare this drive again. Let's do that. So it will be created and will be a part of this network. And when that's done, we should have a new drive with a new ID of 1 and then a new UUID. So to activate that, we will have the ID 1 and pick this UUID here and then activate that one. So if we go back to our cluster again here, we see that we now have 2 drives and one is down. So we are waiting for that one to come up. We can enable our services while we wait here. So system, CTL, status, Ceph, mon, N2. So that is active. Let's enable that one. Enable the manager. And we can also enable the OSD 1. So now all those are enabled and we'll start when the machine starts. We're still waiting for this one that is down. Can take a while for an OSD to actually start up. Let's check the status here. It is loaded, but it hasn't started. Okay. Let's try a restart there. See what we have. We had a problem here. But the service did not start. So let's try to stop it to see if we can do that. And then try to start it again. No. Well, when in doubt, try restart. So let's restart that one. And let's set up node number 3 because we will need that as well. So let's go in here. We will prepare a drive here as well. So this will be our third last drive. If I can type the password correctly. So it's preparing that drive. And see here. So we are using the second node as our manager, and of course that one is down now, so we will try another one and see if we can get any dashboard, see which one was active now. So that one is active. Let's go in here. So now see that we have 3 and 2 down. Let's see if we can activate one more here. So it successfully created that one. It gave it ID 2, and then we have this UUID. Push that in. Nope, that was prepare. I wanted activate 2, and then that UUID. Copy pasting is hard. So see here, it will prepare that one or activate that one. Takes a little while. As these are all virtual machine, it's using my system, and that's doing a lot now that I record as well. But see if it comes up here, or if we just got one of the drives running. Hopefully we didn't. And we see here also that our system is actually healthy now that we have 3 drives, even though two of them are not started yet. So let's see here. Status. We have the manager which has status started. So let's enable the manager and monitor, and then check the status of the OSD. And that failed as well. That's a bit sad. Let's try restarting this one as well. See if number 2 is up and running again. It is. So let's see here. Status of OSD 1. Still failed to start. Let's tail the log here and see if we can get this. Get any information about what happened. Ceph OSD 1 log. Sudo that. So let's see what is the problem here. Stat log. See if we can find anything here that tells us anything problematic. There is a lot of log written about this OSD. Failed to pick cluster address. Okay. Okay. So we don't have any IPv address in the network. So let's see if we have. Might have been a miss from my side here. If we check our network configuration in interfaces, do I have an interface? I have an interface for 212. Okay. .0.12. That's not up and running. Okay. Does this virtual machine actually have the second interface? Because I created 2 interfaces, so I had an intra-network on the second interface here. And if we look at details, it looks like it doesn't really have the second interface. So that's the problem. Let's shut this down again. So I can bring this over so we can see the actual configuration here. So this is the Virtualbox configuration for this. And what I had here in this configuration, I only have the bridge adapter, but I need the internal network address as well, internet, which has that specific address. So the OSD are talking to each other through this cluster network, the network 10.2, and then we had this outward network that is the public network that everyone else uses, and that network is the 192.168 one, and in this case we have the problem that they couldn't really speak to the other OSD, so therefore it couldn't really stop. So let's shut down number 3 as well, so it stopped there, and we go into the settings again, and we will go into network, second adapter, enable it, select internal network, and we should be able to start that one as well, and we're off to the races. So that was a little bit sad. Let's see here if we, when the machines comes up, if they are able to just pick up and can, yeah, so now we see that we have 1 and 0 and we have 2 managers, and now it actually says that 2 are in and 1 are out and 2 are down. So that's interesting. We have 1 up, 2 in, 2 down and 1 out. That's a very interesting mix of OSDs, I must say. So it has now started the OSD 1 on node 2, so it should change up here to actually have 2 in. Yeah, so now we have 2 up, 3 in and 1 is down. So hopefully we will get the last one up and running when this node 3 is started, so I will wait for that. But we can see here that we now have 100 gigabytes of capacity available, and we have only used 10 megabytes, so a very small amount. And now we see that we have 3 in total, 3 up, 3 in, and you see there it started to create 1 page, and that page is now clean. It has created 1 pool, and it also pushed a lot, and now it created 128 pages in this 1 pool, and it's trying to clean that up and keep it up and running. So what happened there? That's interesting. So now we have 150 gigabytes of disk drive over 3 different hosts. If we look at our hosts here, we can see them running. They have a hard drive. If we look at the device health, we can load the smart data, but it will not give us the full smart data picture because we can't really get any overall smart health assessment because the virtual drive is not giving that information to us. And if we look at OSDs, we see that all are up and running, there's no traffic. But if we look in the pool, we see that we already have this device health metrics pool, which have not been used at all yet. But this is something that is created as soon as you have a healthy system with enough OSDs. You will get one of these pools, and the device information will be saved in that pool. So if you have the smart Mon tool that I enabled for us and have this running, the manager module called device health, which is enabled by default, will create this pool and then push device health into that. When you have enough device health, you can start this disk prediction local in order to get a status on how the drives are actually feeling, if they are working good or if you need to replace any of them. But I have a separate video about that. We will not talk more about that in this video. So now we actually have a system with some OSDs. We can save information to this system. We don't have any services that could use this Rados system, but we have it installed. So if we switch over here to my client again, and on this client I actually have prepared a Python script. Let's see here, called test client Python. If we look into that, it can actually talk with the Rados system. I have a configuration file here. I will use my own cluster, home cluster, so I will not show you the keys and so on, but it's a standard Ceph configuration files, and then you put in the value. I can show you another one here, test Ceph, and we can look into a Ceph configuration here. So you add a key ring at the end here, telling you where to actually look for the key. But if we look at this client here, it connects to the Rados up here, Rados cluster, does a connect, it tells us what the FSID is, then takes out some statistics about the cluster, and then I will open the device health metrics. I will list all the objects, and then return the content in those objects. And if we run this Python script here, it will give us the IP addresses of my local home cluster, the cluster ID here, and also we get how much kilobytes are saved, how much available, how much used, and these objects here are the device health, the device metrics objects. You see I get 4 of them. I could have written out the actual IDs of them, but we don't get any data. And I was working with this for a long while, trying to get some data out from these, because you have 1 per drive with health metrics, but whatever you do when you read it, you just get back that the object is 0 bytes large and you don't get any data. So that pool is really weird, and you can't really do any Rados with it. On the other hand, if I run, let's see here, we had a JDK installed here, bin Java, jar, and then I have created this Java Rados snapshot. If I run that, it will go out, connect to the cluster, we'll look at how many objects and so on it is, and then it will actually read 1 object in my cluster using Rados. The librados plugin can actually read data. So now you see here, I got back that this object was changed this time, so modified time. It has this size, the object ID, and then I get the first 10 bytes or so of the actual object. So this is the back end that you will build services on. So there is 3 different services, at least 3 different services that you can run on your cluster that has this Rados layer beneath it that you can actually work with, and you have simple services that will handle all the striping and everything for you, but this Rados layer will handle the distribution of the data over your disks. We will look a little bit at this Java code as well. I have it open in my my little editor here. I will shut down the extra panes here so we can see a little bit more code, because that's the interesting part. There we go. And I will close these Java files. We just look at the actual script. We can look at the Pom file first. So in the Pom file, the only thing I've done here is added the dependency of Ceph Rados, and this is version 0.6.0. So that is something that is available in the Maven repository, so we can run that. If we look at my JavaScript here, or my Java main class here. So here I create a Rados object with the ID admin, so that is the client that I want to connect with. So I use the admin user, or the user admin client. Then I fetch the file for the specific configuration, and then I use the cluster to read the configuration file, and then I print out that I have read it. I connect to the cluster, do a type out of that as well, and then I have this hot storage. That was the pool that I was reading from, so I create a context for that hot storage. Then I will read some pool information about that hot storage, so I know how many objects and how many bytes is stored in that, and that we saw in my output. Then I print out all the snapshots that have been done in this pool. There were no snapshots, so I didn't get any information there, but it is a functionality here, so you can type out all the snapshots, probably get out the data as well, because there is a function called Iostat snap create snap. Yeah, you can. I think it's snap create or snap lookup or something like that, and you set which snap you want to read and write to. I haven't looked into that or played with that. And then we have a list of all the objects that are available. You get back string information. So you have a string that will point to all the different objects in your cluster. And then you have this specific read op, and I will talk a little bit more about that later on. And then we have this Iostat to get statistics from my network. So here we got the modified time, object ID, and size. I can get that from this stat. And then I can read the object, the length that I want to read, number of bytes, and then I print out how many bytes were actually read. And then I do a quick array copy and print out that specific string. So, and down here I will destroy that context as well, so I will not read more from the cluster. So that was how I did to actually just read 10 bytes. I have tried a lot of other things as well. As I talked about here, we have this read operation, and that is if you want to read a lot of data, so large objects, then you create a read operation. You queue up down here. We will comment those. So here you queue up how much you want to read. In this case, it was the same amount of data. And then you have a bunch of these different flags that you can put on here. So we have the Rados, operation balance, ignore cache, and so on. How to read this. You can set no flags as well if you want. And that, when you do that operate, you will use the queued command and do the actual read. And after you have done that, the read result we have up here will have bytes in it. So then I can read how many bytes did I actually read from the cluster, and then I will just push that buffer that was read into these bytes, this byte array here, and then I can get the same output again using a read operation instead. But using Rados in order to read and write objects, it's not really the greatest way to handle your cluster. But if you want to be bare metal, have a really fast implementation, or create something that runs on your Ceph cluster that is not using these specific services, then you will implement it in the this kind of a language. And I believe it's implemented in C, C++, Java, Python, Rust, and there is also bindings for, I think I saw an Erlang binding and so on. So there is a couple of different languages that has different implementation, but they're using the same library. There's librados, and librados is built in C. So you can build something upon this. It's how the cluster is actually saving data, but I would not recommend it. And in the next video, I will talk about the different storage solutions you can use upon your cluster in order to save data and work with data. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you have any comments or suggestions, leave them down in the comment section down below. And I really hope to see you in the next video.